Hi, I thought it would be good to go through my solutions to the mesh analysis homework. Now, this is in WebWorks, so all of the numbers for me are going to be different from your numbers, or at least a little bit. But it's not going to give you the answers, but it should at least help you prompt in the right direction. Now, all of these start out with part one, figuring out what sort of equations we need to use, right? And remember, normally mesh analysis applies Kirchhoff's voltage law. And there's reasons why you might apply Kirchhoff's current law, but in general, we're looking to apply Kirchhoff's voltage law. So for this first one, there's no current sources. The reason why we might need to apply Kirchhoff's current law is if there are current sources. This first problem one circuit only has two voltage sources. So for the first one, all we need is, there are three meshes, so we need three Kirchhoff's voltage law equations and no Kirchhoff's current law equations. Right, and then we've got to apply our Kirchhoff's voltage law to each of the three circuits, right? And three meshes. So let's try the I1 mesh first, right? And go around here, and I'm going to put a plus sign and a minus sign there. So we're going into the minus side of V1, so it's minus V1 plus V out, I'll call it, plus VR2 equals 0. Okay, and then we can convert that into, we can apply Ohm's law, and we can use the numbers we have. So V1 is 14, so I'm going to put the 14 on the other side. V out is going to be R1 times I1 minus I3, and R1 is 9 ohms, so it's 9 times I1 minus I3. Okay, and VR2, R2 is 6 ohms, so it's going to be plus 6 times I1 minus I2. Again, I1 and I2 are going in the opposite direction through the resistor, just like I1 and I3 are going in the opposite direction through R1. So I think that's why I got this one. I left the minus 14 on this side, but I could just as easily have put it over here. Okay, so that's the I1 mesh. The I2 mesh, right? So let's write it up here. I2 mesh, we have, let's just say plus V2, because we're going in the plus side. And in fact, I might just use a different color. So let's go with plus, minus, plus, minus, plus, minus. So we have plus V2, and let me just maybe erase that. Get an eraser, and we can erase that. We'll draw it in green. Right, so it's going to be plus V2 plus VR3 plus VR2 equals 0, and V2 is 10 volts, so I'm going to write that over here, even though it looks like I left it on the other side. So VR3 is going to be just R3, which is 9 times I2, right? 9 times I2, and then VR2 is R2 is 6, so it's 6 times I2 minus I1. and that looks like that's what I got here. And then the last one, I3, right, we're going back this way. I am going to leave V out defined like that, just because I think it might be helpful. So is that the right way to do it? Let's not. I'm going to define VR. I'm going to use VR1, right? So we have for the where can I draw it? Let's do it here. I3 mesh. We have minus V2 plus VR1, which is different from V out, plus VR4 equals 0. So minus V2 is minus 10, and then VR1 is R1 is 9, so it's plus 9 times. Now this is I3 minus I1, right? And then the last one is R4, which is 5 times I3, and that equals 0. And that's where I got that equation, right? And then I need to put all of that into an appropriate matrix in order to solve it. So my appropriate matrix, I need to distribute and group like terms. So that's 15, and then the I2 coefficient is minus 6, and the I3 coefficient is minus 9, and then that's just going to be times I1, I2 and I3, and that equals let's just scoot it over a bit. That equals, and I've got 14 on this side, and then here we've got minus 6 I1 plus 6 I2, sorry, plus 15 I2, because there's a 6 and a 9. Oops, didn't get my eraser. Let's get my eraser. There we go. Right, and then so what was that again? That is going to be 15 I2, and then 0 I3, and then here we've got and there's actually over here there's a minus 10, and then on this one we've got minus 9 and 0 and 9, and then we've got a plus 10 over there. And then I can fire up MATLAB, and I should have done that before I started, so let's just grab that. It might take a while to fire up, and then I can put that into the RF function like you could do on your calculators. I actually looked at getting the Texas Instruments emulator, so I could do it on my use the emulator calculator emulator on my computer, but it's about 3 times more expensive than actually buying a calculator, so I'm not going to do that. I think it doesn't make a whole lot of sense. So let's do this. We'll go for a new script, and let's just make that a little wider. And our A matrix is 15 minus 6 minus 9, minus 6, 15, 0, minus 9, 0, 9, minus 9, 0, 9. And our B vector rather is 14 minus 10, 10. And then I can just say my Q1 I's equals RF AB, and I can just display Q1 I's, and I just need the, it's going to be the fourth column. I think that's right. Let's see what that does. And I'm just going to save that over in, do I have it in homework? No, let's do that there. Don't think I have a separate homework. So this is homework 3, Q1. Right, and so there's some numbers. And that doesn't look like the numbers I got down there. That's kind of interesting. So I got plus 10, minus 10, minus 15. Did I do something wrong? 9 times I2. 6 times I2 minus 6 times I1 equals 0. That looks okay. That's a little disconcerting. Why did I do that? Let's just have a look that A looks right. A looks right. Does B look right? B looks right. Let's just go to the problem and see what happens. Right, so apparently those are all correct. I'm somewhat confused. Nine I1, 15 I1. Right, I got 15 I1. And minus 6 I2 and minus 9 I3. So that line looks good. And then I got 14 and then 9 I2 plus 6 I2 and minus 6 I1 and 0. Where's it gone? Oh, 0 I3. That looks okay. And then minus 909. Aha! Look at that. I've got an. What did I do wrong? I got a 9 there. I didn't add that 9 and that 5, right? So that's my problem. So we do that, and that's going to be a 14 in there, right? 9 plus 5 is 14 I3. So let's see, hopefully that changes our answer to the right one, and that's looking more like what I got before, right? 2.411, 0.2977 and 2.264. Okay, that is problem 1. I'm going to stop this video and I'll do a new video for problem 2.